So today we're going to be talking about a very specific detail. It's probably one of the most important details in high performance buildings, and I want you guys to be able to get it right as well. Welcome along to another video. I'm Roger Borland from Borland Architecture, and this detail in particular is a floor to wall detail. So it's got a concrete slab. This building's got a timber frame, and we're going to actually show you how to put these parts together to ensure that all the different layers work to ensure that the building is going to be high performance in regard from an energy point of view. It's going to make sure that it's healthy and it's keeping all the moisture and mold out of that wall. It's going to ensure that it's airtight so that the energy is maintained inside the building and outside contaminants are not getting inside. And there's three key layers in this type of building. We're going to go through them all. I'm just going to show you how they all connect through this junction and make a high performance building work really well. So stick around for the detail and let's get into it and see it all happen. Okay, so let's draw out this detail. So the first thing we're going to draw is the concrete slab itself. So just to be clear, this is conceptual, it's not been dimensioned, there's no accuracy in this, it's just really been drawn to give you an idea of the different layers and how it goes together. So yeah, not overly accurate, but it should be good. So the concrete slab obviously would sit on the ground, but the problem with that is that the ground actually can be quite cold or quite warm and maybe not the ideal temperature we have inside. And concrete is not a good thermal bridge basically. What it does is it conducts energy quite easily because of the materials that's in it. So what we want to do is ensure that we isolate the slab from the ground itself. So for instance, if it's really hot outside and the ground maybe is 25 degrees, you want your internal temperature maybe to be 18 degrees. And what's happening is that the warm air rushes towards the cold air, and so the hot ground will heat up the slab and it will actually start heating up your internal space, which causes you to need more energy to cool it back down again. Vice versa, if it's very cold outside, you want to have a nice and warm inside. The hot air is going to try and rush from inside to the outside space. And so again, we need to try and create a break between the inside and the outside where possible. So the first thing we're going to do with our slab to create that break is to put a layer of insulation wrapping around all the exposed edges of it. So this is a layer of 50 millimeters XPS insulation. Just drawing it in here. I always find this very therapeutic, drawing these little swirls in place. And it goes up the front face of the concrete as well. So that means now that our slab is separated from the ground, but although this insulation itself is generally quite waterproof, it's closed cell, which means it doesn't allow the water to influence the thermal quality of the insulation itself. Water still will get underneath the slab, and what we really want to ensure that it doesn't get into the slab itself, which would obviously affect the internal spaces. So we put a membrane directly underneath the insulation itself to actually keep that moisture out of the insulation and out of the slab. And so that comes right up to the edge of the insulation again. So I'm just going to color in the insulation just so that it's clear on the drawing on what's what. So there you see it. So we've got our ground underneath here, which is now separated from the slab with two layers. So we've got the weather resistant barrier, so stopping water getting in, and then we've got the insulation barrier keeping the slab nice and isolated. Now we possibly might want an external paving slab through here, so I'm just going to draw in another concrete slab, and this is the external paving area, right? So this could be done a number of different ways. Might not be concrete, it could be pavers, it could be timber decking, whatever the case may be. But it's very important to ensure that we've got a nice step between the inside and the outside, ideally around 150 millimeters or thereabouts. And the other part is we need to ensure that we've got a fall of at least 1:100 away from the building within this external slab itself as well. So that is running the water and any rain that falls on it away from the building, and so that we're actually protecting this junction between the two and getting the water away from the building. Okay, so we've got a couple of pieces in here now. Now, before I draw the next one, I just want to explain the general principles and a little clarity. And we're going to just use this little diagram I prepared earlier. So in this is a section of a building, and here's John, our inhabitant, in here, and he's nice and cozy inside, and he's in a nice healthy environment. And the reason he's in a nice healthy environment is because there are 3 layers in our building envelope that are consistent around all junctions of the building without any gaps. The first one is the green line, and that is what we call the weather resistant barrier, or WRB. And in this case, you can see it's starting to come in here, in this green line, which is protecting. So it's stopping outside moisture getting into the building and protecting the building from that point of view. The second one is the yellow here, which is the insulation layer. And again, we want to keep that nice and consistent around all junctions and all details, so that there are no gaps in this that allow any heat to filter in through any of these gaps from the outside to the inside and vice versa. The third one is what we call the ARB, or air resistant barrier, and that goes on the inside, and that is protecting the energy inside, maintaining it so that we're not getting any drafts coming through the wall structure, floor structure, roof structure itself. It's also maintaining a healthy environment by stopping outside contaminants coming through and getting through that barrier. So it's creating a barrier between you and the outside in regard to air, and keeping it nice and comfortable, healthy, and energy efficient on the inside of the building. So those 3 layers are really important, and every time we draw a detail, we want to ensure that we're thinking about those 3 layers and everything and keeping them consistent. So when I'm doing this next layer, this is going to be a timber frame wall structure, 140 millimeters. And so this is the base plate I'm drawing in here. And you'll notice what I'm doing here is I'm overlapping the outside of this base plate with the slab, so it aligns with the outside of the insulation. And what this is doing is, as I build my wall on top of this, and then we put insulation into this wall, what you should be able to see is a nice straight line of these yellow surfaces happening. So we've got insulation stacked on top of insulation, and the timber stud itself, being timber, is actually got quite low thermal conductivity. Not quite as good as the insulation, but much better than concrete, and much better than steel. So it's actually an insulator in its own value, although it is creating a small thermal bridge through here, but not too much to be concerned about in timber. So we've got one of our key layers in place here that's acting consistently through it. The second one we're going to put in is, now we're going to put a weather resistant barrier or membrane on the outside of the timber stud, and we're going to put a tape at that junction between the one that we put onto the slab and the one that we have on the wall. And that maintains a nice consistent airtight seal the whole way around the outside of the building. Now, there's something very important I need to tell you about this particular membrane that we put on here. This needs to be a class 4 membrane. That means that this type of membrane is very clever. What it does is, as I mentioned, it stops any rain and moisture coming from the outside to get into this wall structure. So it's acting as a barrier from the outside. But what happens on the inside is that people inside here, whenever they're cooking, they're cleaning, they're breathing generally, we're creating moisture. And the majority of that moisture in a high performance home is being extracted through the mechanical ventilation system. However, some of it will get into the wall structure and the structure of the building generally. And so as that moisture comes into this wall structure, what we want to ensure that happens is that whenever it gets to the back of this membrane, that it's not prevented from carrying through. So a class 4 membrane provides no barrier to this moisture carrying through from the inside. And so it's vapor open is the term they use, which allows that vapor, water vapor, to carry through the wall right through that outside membrane. So it's stopping moisture from the outside, but allowing moisture to come through it from the inside. So it's very clever. Okay, so now we've got 2 of the layers in place. The third one we're going to add on the inside, and that is the air resistant barrier, or ARB. And we're going to apply it to the inside of our stud, and we're going to put some tape between that membrane and the slab at the bottom. And the slab itself is actually quite good from a air resistant point of view, as long as there's no penetrations through it. If they are, they need to be sealed up as well with various grommets and so on that you put in to stop any air leakage through those. But generally, we've got a red line, which is the air resistant barrier on the top of the concrete, being connected to the barrier on the inside and creating a nice consistent line on the inside of the building. So we've now got all 3 of the layers in place. We've got the air resistant barrier, we've got the insulation layer, and we've got the weather resistant barrier on the outside. Now, what we need to do is ensure we protect all 3 of these layers, because there's no point in doing this if we're then going to cut holes in it. So if we cut holes in the air resistant barrier, it creates a leak in it, obviously, and it defeats the purpose. If we penetrate into the insulation and put services into this, it reduces the thermal quality of this insulation, and therefore, again, we're just kind of defeating the purpose of it. And again, if we cut holes in the outside membrane, we're allowing moisture to get into the building, which we don't want. So on the inside, what we want to do is we want to create a vertical batten, which is 45mm thick typically, and then we apply our plasterboard to that batten. So in here we've got a vertical batten 45mm thick running vertically through here. And what that does is it allows this gap, and this gap is where we're going to apply our services. So this is a power point that I'm drawing in here, and it penetrates through the plasterboard obviously, and the back of the plug comes into this space, and then you do your wiring in this space. Same with your plumbing, small plumbing, you know, they run in this space as well, and it doesn't penetrate through any of the red line, the yellow line, or the green line. So they're protected. What's more is that this gap then can be further insulated. So you can add more insulation into this once you've got your services in, so that we've given ourselves a bit of a boost in regard to the insulation value. So our 140 stud, if we put in say earth wool into that space, you'll achieve around a R4 rating for that, and with a further 45mm of earth wool on the inside, you'll get a further R1. So that adds up obviously to R5, which is approximately twice as good as a typical wall required under Nathers and the standard code. So this is now performing really well from a thermal point of view, right? It's what we consider to be a high performance wall. And what's more is we've protected this air barrier on the inside. Likewise, we need to protect the membrane on the outside. And though again, what we do here is we put another vertical batten down this edge of the building. And that is going to ensure that we get, again, an air gap in this space running vertically through the building. So what that air gap does is very important. One is this moisture, which we've been talking about, that gets inside the building. Whenever it gets to the outside, gets into this space. And it can either drip down and out the bottom, or if it's just small amounts of moisture, what happens is the gap that we're creating at the bottom allows air to come into this space at the bottom, and it allows it to be exhausted out the top. So it's creating a little bit of a chimney effect inside behind the cladding. And this is constantly drying this internal cavity space and ensuring that any moisture that does get into that space is not getting into this wall structure. It's not creating any mold, and it's not degrading the structure generally. So that vertical batten is doing an important job to do that. So in this particular detail, I'm going to draw on a vertical timber cladding. So it sits out a little bit further again in this sort of area here. Sorry, that's not quite well drawn. And that is on some horizontal battens that are fixed onto the original vertical batten that we put on, because we need horizontal battens to do vertical cladding. So we've got two separate battens in opposite directions here doing two different things. One's holding the cladding, the other one is allowing that ventilation gap to run through nice and consistently. So there you have it, folks. That's how this detail comes together. You can see there's quite a lot to it, but in general it's quite simple once you know the principles. So hopefully this little drawing exercise has shown you what those principles are, and you can now understand it. Thank you for watching. I hope you found that really useful. We really want you to be able to grasp these ideas quite simply and use it yourself. And we want to do that because we want to ensure that 1 million people out there are going to be able to pick this sort of detail up and design it themselves and be able to create buildings that are high performance and understand the consequences of not doing it the right way. If you've got any questions at all, please reach out and give me a comment or send me a direct message. Happy to be there to help you through these particular queries that you might have so that you can do it better. If you know somebody else who's going through this, share this video with them as well. Otherwise, like, subscribe, and we hope to see you in the next video. Thank you.